Hello viewers, my name is Mr. Adebanjo, and I want to welcome you to my channel. Today we are going to be discussing extensively on logarithms. We are going to be discussing in this video logarithms. And why do we have to discuss logarithm? Logarithm is one of the important topics in mathematics. Just like in the previous video, we discussed extensively on indices. And I promise in that video that we are going to discuss logarithm in the next video. And we know that indices and logarithm are interrelated. So that is why I deem it fit to make video on logarithm in order to complement indices. So if you have not watched the video on indices, please check my playlist as you are going to see the video on indices if truly you want to understand logarithm, because I must tell you that they are interrelated. They are really interrelated. So if you want to understand logarithm very well, please, you must understand indices. So like I said, you are going to be discussing extensively on logarithm in this video. Logarithm is one very important in mathematics, and understanding of it will help you a lot in knowing mathematics, because logarithm is also applicable to other area or topics in mathematics. So you must understand logarithm very well if really you want to understand some other topics in mathematics. Now, what are we going to be doing in this video? We are going to be telling you what logarithm is all about, and we are going to be telling you the ways of solving logarithmic questions. We are going to be showing you the solution to logarithm by definition, and we are going to tell you the laws of logarithms, and also solution to logarithm using the laws. And also we are going to solve a past question related to logarithm as well. So this video is going to be a bulky one, and it's going to help us a lot very well. So if you are, before we get it started, if you are yet to subscribe to this channel, please click on the subscribe button right now on the channel, so that you will be notified whenever we post information on this platform. And also share the video, like the video, so that you help us improve this video, and share the video with other students who need this resource material out there. Dear viewers, I want you to remember today that Jesus is Lord, to the glory of the God the Father. Make Jesus the Lord of your life today. In everything you do, you need Jesus. He is the Lord and the personal Savior God has sent to us. So is the Lord and the only Savior God has sent to us from the heaven to the earth. Make him the Lord of your life today. Make him the Lord of everything that concerns you, the Lord of your family, the Lord over your work, the Lord over everything you have. And those things will never remain the same. Make him the Lord over your wisdom, the Lord over your understanding, the Lord over everything that exists in your life. And I know that your life will never remain the same if you do that. And if you are here to accept him as your Lord and personal Savior, do that today, so that it might be well with you, because tomorrow might be too late. Like I said, we are going to be telling you the ways of solving logarithm questions or logarithmic questions. There are ways of approaching logarithms. I must tell you, if truly you want to understand what logarithm is all about, there are ways of approaching it. You just don't approach logarithm question or logarithmic question anyhow. There are ways you must know that you must know to approach a logarithmic question. Let me take you back to quadratic equation. We all know that a quadratic equation is an equation with the highest power of the unknown to be 2. As a result of that, there are methods of solving quadratic equation ranging from factorization method to completing the square method to formula method and to graphical method. Why do we have all these methods? So that we know that quadratic method, factorization method cannot solve all quadratic equation. It's limited. That is why there are other methods. The same thing is applicable to logarithms. Logarithms, there are some questions that we can solve mere using the definition of logarithm. There are questions that can be solved on logarithm just by using the definition of logarithm. And there are also some questions that you can solve using the laws of logarithms. And there are also some questions on logarithm that you can solve using the logarithm table, which is also called four-figure tables. So as far as I'm concerned, I divide the solution of logarithm table to these three parts, or to these three ways. You can solve logarithm question or logarithm question using the definition of logarithm, using the laws of logarithms, and using the logarithms table, or that is also called four-figure table. So we are going to, in this video, you are not going to attempt all the three ways as I've highlighted in this on the screen right now, but we are going to cover the first two ways. This third way we are going to cover in another video coming very soon. So we are going to cover how we can solve logarithm using the definition of logarithm. We are going to cover how we can solve logarithm using the laws of logarithm in this video. This video is very uh, bulky, and it help us. It's going to help us a lot, as we are going to cover lots of questions using the definition of logarithm and using the laws of logarithm. So let's get this started without wasting much of our time, using what you have going to discuss here: the definition of logarithm and the laws of logarithm. The question is, what is logarithm? That's the question we need to ask ourselves. What is logarithm? Of course, students will tell you that nobody is going to ask them what is logarithm in the examination. Of course, since it's not an English or other storytelling subject, it requires calculation. So they only ask them to solve questions. But I must tell you that when it comes to logarithm, the definition of logarithm itself can help you tackle some question. So understanding the definition of logarithm itself can help you solve some question in logarithm without any stress. So let's talk about the definition of logarithm. Logarithm of a number. That means you can find a logarithm of any number. That's the first thing you need to know. You can find the logarithm of any number in a given base. That means that logarithm you are dealing with must be in a particular base. So the default base of logarithm is base 10. So if I write a logarithm and I did not put any base, that means it's automatically in base 10. So that means every logarithm you are going to be working on must be in a particular base. So it could be in base 10, it could be in base 2, it could be in base 5, and any base that you can think of. But you must know that if you are given a logarithm and they did not put any base, that means it is automatically in base 10. You must know that as a student. So logarithm of a number in a given base is the index. Another name for index is power. We talk about that in under indices. So another name for index is power. Is the index to which the base must be raised to get the number. The logarithm of a number in a given base is the index to which the base must be raised to get the number. You may not understand this very well, but I'm going to explain it in a layman definition. That is, how often can you raise the base to get the number? That's the meaning of logarithm. If I have logarithm of logarithm of 4 base 2, logarithm of 4 base 2, what does that logarithm of 4 base 2 means? It has a meaning. That's the first thing I want to pass across to students. Don't just see it as logarithm of 4 base 2. it does has a meaning. It's meaningful. Logarithm of 4 base 2 means how many times can you raise 2 to get 4? That's the interpretation of what is given to you. How many times can I raise 2 to get 4? By now, I believe you know the answer to that. How many times can you raise? What will be the power of 2 to get 4? That should be 2. So that means logarithm of 4 base 2 is 2. As simple as that. So with this definition, it's saying that how often can you raise the base to get the number? That's the meaning of logarithm of that number in that particular base. I hope you understand what I'm trying to say. Logarithm of a number in a given base is the index to which the base must be raised to get the number. That is, how many times can I raise the base to get the number? That's the meaning of logarithm for you. Look at this now. You're having n is equals to a raised to power x. We can change this to a logarithmic equation or a logarithmic form. N is equals to a raised to power x. That means I'm raising a x time to get n. That's what this one means. I'm raising a s time to get n. So if you compare it to what you're having here, that means you'll be having the log of this n in base a now to give us what x. The logarithm of this number n in base a to give us what x. So that means logarithm is talking about how many times can you raise this base a x times to get what n. So how often can I raise a? How often can I raise a with this x to get what n? Am I communicating at all now? So the logarithm of a number in a given base is the index. That is what will be the power of a to get what n. That's the meaning of logarithm. If you understand that, let's try to see some things, some example rather. Look at this now. You're having log of 8 base 2. What does this mean? Or what does this mean? What is the meaning of this statement you're having on the screen right now? Log of 8 base 2. I want to know that this is not about just solving the question. This has a meaning. It's meaningful. What does it mean? Because its meaning can help you solve the question without even taking your biro to work anything out. So the logarithm of this number 8 is saying that, okay, the logarithm of this number 8 base 2 is saying that what will be the power of 2 to get 8? That's the meaning of this statement here. What is the index of 2 to get 8? How often can you raise 2 to get 8? How many times can you raise 2 to get 8? What is the power of 2 to get 8? So I'm just giving you different definition or different meaning to this statement on the screen right now. The logarithm of 8 base 2 is how many times you can raise the base to get what? 8. If I ask you what's the answer, by now you should know the answer. So the answer is what? 3. So 2 raised to power 3 will give us what? 8. So the logarithm of 8 base 2 is what? 3. So the answer is 3. Logarithm of 8 base 2 is what? 3. That means I can raise 2 3 times to get what? 8. That is 2 raised to power 3 will give us what? 8. Do you understand that? Let's see another example. We are having logarithm of 81 base 3. What does it imply? Logarithm of 81 base 3. What does it imply? Or how can you interpret that question? How can you interpret logarithm of 81 base 3? It means that how often can you raise 3 to get 81? What is the power of 3 to get 81? How many times can you raise 3 to get 81? So that's the meaning of this logarithm of 81 base 3. If I ask you what will be the answer? How many times can you raise 3 to get 81? So the answer is 4. Logarithm of 81 base 3 is 4. You can raise 3 4 times to get 81. 3 times 3 times 3 times 3 give us 81. So the answer is 81. So I believe, sorry, answer is 4 rather. I believe you understand what, by definition of logarithm, you can even solve some question without taking your biro at all. Saying that this implied that how many times can I raise 3 to get 81? The logarithm of a number in a given base is the index to which the base must be raised to get this number back. It is the index to which the base must be raised to get the number back. How many times can I raise this base to get 81? And that should give us what? 4. So 3 raised to power 4 will give us what? 81. That's the meaning of this logarithm you are having here. So having understood what we have explained so far, so let's use that idea to solve all these question 1 to question number 6. Question say evaluate the following without using tables or calculator. So these questions are very familiar to objective questions and even JAMB question as well. So we have to evaluate the following without using tables or calculator. The first one, we have a logarithm of 81 base 3. I think we have solved that one before in the previous slide. But let's see how we can do the calculation aspect of it. That is, how can we solve it step by step? Although we know the answer to this, that a logarithm of 81 base 3 is what? Is 4. That is, we can raise 3 4 times to get what? 81. So now, how do we show the the solution of this? Knowing fully well that the answer is 4. Now, since we don't know the value of the number of times we can raise 3 to get 81, so we can set the logarithm of 81 base 3, let it be x. That is, the answer is x since we don't know it. So that means using the definition of logarithm, I can raise 3 x time to get 81 according to the law definition of logarithm, saying that how many times can I raise 3 to get 81? Do you understand this at all? Since we don't know the answer, you can say let the answer be what? Equals to x or y or any variable you want. So how do you interpret this? How many times can I raise? Because we are looking for the power of the base. Do you understand that? We are literally looking for the power of the base, which is how many times can I raise the power, which is our in this case now is x. How many times can I raise? Sorry, how many times can I raise this 3 with this power x to give us what? 81. So that's what gives us this. So 3 raised to power x equals to what? 81. If I want to change this one back to logarithm, I will have logarithm of 81 base 3 is equal to what? X, which is this at the back. So we are looking for the power of x now. Since we don't know the power of x, we are looking for the power of 3 rather. Since we don't know the power of 3, you can call it x. Then 3 raised to power x equals to what? 81. So if you understand indices very well, you know what to do from here. If you understand indices, you will know what to do from here. That we can change 81 also to index form so that they can have the base of 3 as well. And that should give us 3 raised to power 4. So 3 raised to power 4 will give us 81. And why are we doing this? So that the base can cancel the base here. Since they have the same base in the both sides, so the base can cancel the base. So our s is 4 in this case. So we can raise 3 4 times to get what? 81. Does that make any sense to you? Let's look at the next one. Logarithm of 1000 base 10. If I ask what is the logarithm of 1000 base 10, how many times can you raise 10 to get 1000? Don't look at the solution here. Just tell me the answer offhand. How many times can you raise 10 to get 1000? That's the meaning of this logarithm you're having here. And that is 3. What is logarithm of 100 base 10? That is 2. What is the logarithm of 16 base 2? That should give us 4. What is logarithm of 36 base 6? Logarithm of 36 base 6. That should give us how many? What? 2. Because you can raise 6 2 times to get 36. What is logarithm of 10,000 base 10? 10,000 base 10. How many can you raise 10 to get 10,000? So that should give us 4. So I'm just trying to test your ability on logarithm using the definition of logarithm now. Let's solve this question. We can say that the answer is y since we don't know the answer. So we can now say that 10 raised to power y will give us a 1000. And we can change 1000 to an index form. That should give us 10 raised to power 3. And the base can take out the base. So y will be equal to 3. So you can see that how we get the get the answer to be 3. We can raise 10 3 times to get what? 1000. Still using the definition of logarithm to solve this logarithmic question. Let's look at question number 3. We are given log of 0.0625 base 4. how many times can we raise 4 to get 0.0625? Humanly, you would think that this is not possible, but I must tell you it is possible. You can raise 4 number minus 2 times. That is 4 raised to the power minus 2 will give us a 0.0625. So, but since we don't know the answer, we can call the answer x. So log of 0.0625 base 4 equals to x. So that means we can raise 4 x time to get 0.0625 according to the definition of logarithm. Then this we can change to a fraction. That will be 625 divided by 10,000. Can move the decimal point to the back of 5 here. 1, 2, 3, 4. So that gives us over 10,000 here. Then 625 can go in 10,000. So that will be 625 and 625 give us 1. 625 and 10,000 give us 16. So using the idea of indices, we know what this one literally means. 1 over 16 means inverse of 16. That should give us 16 raised to the power minus 1. So we can now change this 16 to an index form so that I can have the base of 4. Then that will give us 4 raised to the power 2. And that will multiply minus 1. That should give us 4 raised to the power minus 2. Please, if you want to understand these basic things we have done here, you may refer to our teaching on indices. It will enlighten you the more. So 4 raised to the power 2, that 2 times minus 2 give us 4 raised to the power minus 2. Then the base can cancel the base, so s will be equal to minus 2 in this case. I hope you understand this now, that we are still using the definition of logarithm to solve all these basic questions. Let's look at another question. You're having log of 1.21 base 1.1, log of 1.21 base 1.1. That is, how many times can you raise 1.1 to get 1.21? How many times can you raise 1.1 to get 1.21? Is it possible? Let's see. So since we don't know the answer, you can call the answer x. So that means we have 1.21 raised to power x. 1.1 raised to power s will give us a 1.21. Then what can we do here? You can change this decimal number to a fraction. So that should give us 11 over 10. If you understand how to change a fraction to how to change decimal number to a fraction, that is primary school work. You can move the decimal point 1 outside there. That will give us 11 over 10 raised to power x. You can also change this one to a fraction. That should give us 101 divided by 100. 1, 2. That should give us 100 over under here. Then also, this 121 is a perfect square, and 100 is also a perfect square. So 11 square will give us 121. 10 square will give us 100. So also this can also be written as 11 over 10 all square, meaning that this square is affecting 11, which is this, and this square is also affecting 10, which is this as well. So, and you can see that we are having an index of x with base of 11 over 10. We are having the index of 2 with the base of 11 over 10. So the base are equal at both sides. So you can cancel out the base. Then the s will be equal to what? 2. So that means I can raise 1.1 2 times to get 1.21. That is 1.1 times 1.1 will give us 1.21. That's what it means. Does that make any sense to you at all? If it does, let's look at the question number 5. You have to find the logarithm of 128 base 0.125. How many times can we raise 0.125 to get 128? Humanly, it is not possible, but I must tell you it is possible with calculator or with computer or with 4-figure table. But we are still going to use the logarithm, the definition of logarithm to solve this as well. Now, how do we approach this? You can call the value, since we don't know the answer, you can call the answer p. So let the logarithm of 128 base 0.125 be p. So that means we can raise 0.125 raised to power p to get 128 according to the definition of logarithm. So since we are looking for the power now, which is p, then we can change this decimal number to a fraction. That should give us 125 over 1000. Then raised to power p equals 128. Then 125 can go in 125. 125 can go in 1000. That should give us 1 over 8 raised to power p equals 128. Then this 1 over 8 can be changed to 8 raised to power minus 1. 8 raised to power minus 1 using the idea of indices. So this is inverse of 8, which can be written as 8 raised to power minus 1. Then that power minus 1 will multiply p, and that should give us minus p. Minus 1 times p gives us minus p. So we have 8 raised to power minus p equals 128. We can also change this 128 to an index form, and that should give us 2 raised to power 7. We can also change this 8 to an index form. That should give us 2 raised to power 3. Then that 3 will multiply minus p, and that should give us 2 raised to power minus 3p. Then the base can take care of the base in this case. Then you have minus 3p to be equal to 7. Then you can divide both sides by minus 3 to give us p to be equal to minus 7 over 3. And that should give us a minus 2 1 over 3. So we can raise 0.25 minus 7 over 3 times to give us 128. We can raise 0.125 minus 7 over 3 times to get 128. I hope you understand that. That if you put your your p here, the value of your p, you can put it here, 0.125 raised to power minus 7 over 3. It will give us this value. So that's what it implies. Let's look at this question. We're having log of sod 128 base 2 sod 2. We have to find how many times we can raise 2 points sod 2. That's a 2 points, sorry for that. How many times can we raise 2 sod 2 to get sod 128? How often can we raise 2 sod 2 to get sod 128? So since we don't know the answer, we can say the answer is y. Then we have 2 sod 2 raised to power y to be equal to sod 128. Do we understand that? So from there, what can we do? Your idea of indices will help you a lot here. If you understand indices very well, you understand this now. We understand what square root means. Square root means square root of 2 means 2 raised to power half. This square root means raised to power half. So you can say this is 2 times, because this 2 is multiplying this sod 2. This 2 is multiplying sod 2. Therefore, that means you have 2 times 2 raised to power 1 over 2, because this square root means raised to power half. So then raised to power y here. And this one also can be written as 128 raised to power half, because this square root means raised to power half, according to our idea of indices. Then from there, what can we do? You can apply the law of indices to this bracket, since that this is 2 raised to power 1 times 2 raised to power half. They have the same base, so we can pick one of the base and add the power. So you have 2 raised to power 1 plus half, then raised to power y here, equals to, we can change this 128 to an index form, and that should give us a 2 raised to power 7, then raised to power half. Then this can be, you can simplify this power further. 1 plus half will give us 3 raised to power 3 over 2 rather. 1 plus half, if you simplify this using finding the LCM, that should give us 3 over 2. Then you have 2 raised to power 3 over 2, then raised to power y, equals to, according to the law of indices, this 7 will multiply 1 over 2 here, and that should give us 2 raised to power 7 over 2 as well. Then from there, law of indices says that this power also 3 over 2 will multiply this y, and that should give us 2 raised to power 3y over 2 equals to 2 raised to power 7 over 2. And look at the both sides now, they have the same base, which is 2, 2. They can cancel out. So you have 3y over 2 equals to 7 over 2. Then from there, we can cross multiply. We can cross multiply so that we can find out y. Or, even though if you don't want to cross multiply, they have the same, look at this over 2 over 2 here, they can cancel out. 2 can cancel out these 2 here, even though if you don't cross multiply. But if you cross multiply, you have this multiply 3y, and that gives us 6y. Then 2 multiplied by 7, that gives us 17. Then you can divide both sides by 6, that means y is equal to 14 over 6. And 2 in 7, 14 is 7, 2 in 6 is 3, and that gives us 2 over 1 over 3 as the value of our y. So I can raise 2 sod 2 raised to power 7 over 3 to give us a sod 128. That's what this one literally means. I hope you are following me very well. So let's solve more questions using the definition of logarithm to solve question. We have a logarithm of x base 10 to be equal to minus 3. You have to find the value of x. In this case, you are given an equation already. That is, they have raised 10 to the power of minus 3 to get x. So what will be our x in that case? Even if you understand very well, you should read to tell me the answer of this one offhand before even solving the question at all. You are raising 10 raised to power minus 3 to get what? X. So what will be our x? What will be our x? Alright, let's see. So according to the definition of logarithms, how many times can we raise raise 10 with minus 3 to get x? How many times can you raise 10 with minus 3 to get x? So from there, that means you'll be having x equals to 10 raised to power minus 3. And the 10 raised to power minus 3 can be written as 1 over 10 raised to power 3 according to the indices. S is equals to 1 over 10 raised to power 3. Then what is 10 raised to power 3? That will give us S to be equals to 1 over 1000. So that means if you raise 10 raised to power minus 3, that should give us a 1 over 1000 or 1000 raised to power minus 1. I hope you understand this as well. So also you can also have a logarithm equation, and with that you would not know the base. That is, you don't know the base. In this case, we don't know the number, so you find the number using what is given to us. In this case, we don't know the base. We know the number and we know the answer, but we don't know the base. So how do we approach this one as well? So you're having log of 32 base x to be equal to 5 over 3. That is, how many times can we raise x raised to power 5 over 3 to get 32? So how can we find our s from there? So technically, you'll be having s raised to power 5 over 3 to be equal to what? 32. So we have s to be raised to power 5 over 3 equals to 32. Then from there, the question is, how can we get rid of 5 over this power 5 over 3? Because our aim is to find x. How can we get rid of 5 over this power 5 over 3 so that we can get our x? So if you have watched my video on indices, we have solved something like this on indices. A question like this was given to us on indices. So that's why I said indices and logarithm are very, very interwoven. So you may need to refer back to that video on indices if you want to understand logarithm very well. So how do we do this? This one literally means s raised to power 5 times 1 over 3. S raised to power 5 times 1 over 3. So we can get rid of 1 over 3. That is, this is cube root of s raised to power 5. Cube root of s raised to power 5. How can we get rid of cube root 1 over 3? Is by cubing it. So we take the cube of this, then that is multiply the power by 3. And what you do to this side, you do it to this side as well. So 3 will cancel 1 over 3 here. So you have s raised to power 5 left. And 32 raised to power 3 will give us 32,768. Then how do we get rid of this raised to power 5? Is by finding the fifth root of this. Find the fifth root of this. You have a fifth root of s raised to power 5. Then you take the fifth root of this as well. Then you have your s to be equal to 8. So because fifth root will take care of this raised to power 5, so we have x left. Then fifth root of 32,768 is 8. So our x is 8. So that means I can raise 8 raised to power 5 over 3 to get us 32. That's what that literally means. So look at this as well. Let's use that our understanding of definition of logarithm to solve this question as well. We are having the log of s squared minus 6s plus 60 base 10 to give us 2. How many times can we raise 10 raised to power 2 to get whatever we have in the bracket? That's still the same thing we are having here. So that is, we can raise 10 raised to power 2. Or you can raise 10 two times to get this whatever you have in the bracket. So we have to get the value of x in this case. Then how do we do that? It's very simple. Be using the what we have been using so far. So you have 10 raised to power 2, which is this, to give us whatever you have in the bracket, s squared minus 6s plus 60. So as the interpretation of logarithm, then from there 10 raised to power 2 is 100. Then you can collect like times. You have s squared minus 6s plus 60 minus 100 to be equal to 0. Then 60 minus 100 will give us minus 40. then this is now a quadratic equation to solve. A quadratic equation to solve using any method you know, but we can use factorization method to solve this right now. How do we do that? Look for two numbers you can multiply together with their sign to give us minus 40, and when you add them together to give us minus 6. Two numbers you can multiply together to give us minus 40, and when you add them together it give us minus 6. What are those numbers? We have minus 10 plus 4. Minus 10 plus 4. What is minus 10 times 4? That will give us minus 40. What is minus 10 plus 4? That will give us minus 6. So those numbers will now replace this minus 6x here. So you have minus 10x plus 4x. Minus 10x plus 4x will replace minus 6x. So we have x squared minus 10x plus 4x minus 40 is equal to 0. You can now factorize these two. Something is common to this, which is x. Bring out x. We have x inside minus 10. Something is common here also. We have 4 into s minus 10, close the bracket. So you are meant to have these two brackets to be equal, to be the same thing, then equals to 0. So you bring s plus 4 together and pick one of the brackets. If you pick one of the brackets, you have s minus 10 equals to 0. So from there, that means s plus 4 is equal to 0, or s minus 10 is equal to 0 as well. From there, you can find your x, because this is a linear equation now. So take your quadrilateral times here, s will be equal to minus 4. Quadrilateral times here, s will be equal to 10. So that means the value of our x here is going to be minus 4 or 10, which you can confirm your answer. Let's pick 10 for an example. 10 raised to power 2 will give us 100. Then minus 6 times 10 will give us minus 60. So 100 minus 60 will give us 40, right? 100 minus 60 will give us 40. Then 40 plus 60 will give us 100. So how many times can you raise 10 to give us 100? Log 100 base 10, what will it give us? 2. That means it's correct. Do you understand what I'm trying to say now? Log 100 base 2. How many times can you raise so log 100 base 10? How many times can you raise 10 to get 100? That is 2. You can also use this one to confirm as well. Put your minus 4 here. Minus 4 square will give us 16. Then put your minus 4 here. Minus 4 times minus 6 times minus 4 will give us plus 24. Plus 24 plus 16 will give us 40. Plus 24 plus 16 will give us 40. 40 plus 60 will give us 100. So log of 100 base 10 will give us 2 as well. So that means this is what? Correct. Are we there? So if you understand how to use logarithm, definition of logarithm to solve question on logarithm, then you can try this self-evaluation question yourself. Look at all these questions, 5, 6 questions that we have there. Pick your biro and simplify them one after the other, and you can leave your answer in the comment section of this video, and I will confirm if you are right or wrong. Log of 10,000 base 10. How many times can you raise 10,000 to guess? So how many times can you raise 10 to get 10,000? Log of 1 over 81 base 3. How many times can you raise 3 to get 1 over 81? If you understand indices, there's a way you can rearrange, you present this. This one should give us log 81 raised to power minus 1 base 3. So how many times can you raise 3 to get this? How many times can you raise 3 to get 729? How many times can you raise 4 sod 2 to get sod 512? How many times can you raise 4 to get 0.5? How many times can you raise x raised to power 2 to get 64? These are simple questions you can lay your hands upon, and please share me your answer so that I can confirm it. Now that we understand the first part of this video, that is using the definitions of logarithm to solve some question in logarithm, let's see the other part of this video, which is talking about the laws of logarithm. The laws of logarithm. How can we use the laws of logarithm to solve other question using the other question on logarithm? So before we do that, we need to first of all understand what the laws of logarithm are talking about. What are the law saying, or how do we interpret the law? Now the first law is what you're having on the screen right now, log AB. What does the meaning of AB? Log A times B. Log A times B. Well, how can we write it? A times B can be split to log A plus log B. Log AB can be split to or splitted to log A plus log B. I want you to understand this very well. Look at this now. You're having a single log into bracket A times B. So when times become plus rather, times here become plus, just like when you have it under indices as well. So times here become the plus. But when you're having plus, you can see each of these terms are having their own logarithm. So I have log A plus log B to give us this. So log AB, which is log A times B, will give us log A plus log B. So when it was multiplication, we have a single log. When it is addition, each of the number here have their logarithm. So what if I have log ABC? What will it become? Because I want you to know that it can continue. It's more than this. I can have log ABCD, knowing that ABCD is saying that A times B times C times D. So what would it become here? You'll be having log A plus log B plus log C plus log D. Do you understand that now? So it does not end there, it continue. Another thing I want you to know is that you can move from the left to the right, and you can also move from the right to the left, depending on the question given to you. I can be giving question in this format, then we break it down to this. I can also be giving question in this format like this. Now we break it down, we simplify it to this. So depending on the way it is given to you, so you can move from the right to the left and from the left to the right, depending on the question given to you. So if I'm giving question in this way, I can change it to this way. If I'm giving it this way, I can break it down like this. Let's see the second law. We're having log A over B to give us log A minus log B, knowing that division change to what? Subtraction. And here you're having, when it is division, you're having single log, and when it change to negative, each of these term have their own logarithm. Am I communicating as well? Also, this continue as well. I can have log A divided by B divided by C. That means I'll be having minus log C as well here. I hope you understand that. And also we can move from the right to the left. Sorry, from the right to the left and from the left to the right as well, depending on what is given to us. So if I'm giving log 2 over 5, I can change to log 2 minus log 5. And if I'm giving log 2 minus log 5, I can change to log 2 over 5. So depending on the way it is given to you. So this is the second law of logarithm. The third law of logarithm said that a logarithm of a base a, what will it give us? 1. How many times, according to the definition of logarithm, how many times can I raise a to get a? That is 1. Log a base a is what? 1. So this is a law, but we should understand what this one means as well. That is, how many times can I raise this base to get this number a? This is what? 1. So that means log 10 base 10 will give us 1. You can raise 10 one time to get 10. Log 1000 base 1000 is 1. Log 1 base 1 is 1. Log 2 base 2 is 1. Log 3 base 3 is 1. Log 8 base 8 is 1. Log 5 base 5 is 1. Log any number, and when the base is the same, that number is going to give us 1. So I hope you understand this very well. So let's see the second another law. When I have a logarithm of a number and that number has a power, logarithm of a number and that number has a power, that means the law say that the power will go to the back of the log here, this place. So you have m log a. So also if I have m log a, if I have a logarithm and there is a number before the logarithm, in this case, that means the number will come to this one will go become the power of this number here. So you have this back. So you can go from here to here. I can go from here to here. So I'm giving question like this. Let's say I'm giving 2 log 5. That means it will be log 5 raised to power 2. That 2 will go to the power of 5, like this one. So depending on what is given, so if I'm giving something like this, I will express it like this. If I'm giving something like this, I will express it like this. Am I communicating as well? So let's look at the next law. When I have law of logarithm of 1 base 10, what will it become? How many times can I raise 10 to get me 1? How many times can I raise 10 to get me 1? That will be 0, because 10 raised to power 0 will give me 1. Anything raised to power 0 in mathematics is what? 1. So 10 raised to power 0 will give me 1. So that means a logarithm of 1 base 10 is what? 0. So that means a logarithm of 1 base 2, what is it? 0. Logarithm of 1000, sorry, logarithm of 1 base 1000 is what? 0. Logarithm of 1 base 5 is what? 0. Logarithm of 7, sorry, logarithm of 1 base 7 is 0. So when you're having the logarithm of 1 base anything, it's going to give us 0. Logarithm of 1 base anything is going to give us 0. Because if I have logarithm of 1 base 7, how many times can I raise 7 to give me 1? Is it not 0 times? So that is that, another law for you. Then the last law is how we can change from one base to another in logarithm. How you can change from one base to another. You can change from one log to another. So like you're having log b base a, you can change to base c. So how will you do that? You can change this base from base a to base c. How do we do that? So you write logarithm of b, then logarithm of, oh sorry, divided by logarithm of a, then you put the new base c and c. So you have been able to convert logarithm b base a to base c now. So what did I say? If I want to convert this base to base c, then what do I write? I'll write log b divided by log this base, which is log a. Then you put your new base to up and down, cc. So when I have logarithm of 5 base 2, logarithm of 5 base 2, some of us that are using scientific calculator like Casio is automatically in base 10, so we cannot convert. You cannot solve logarithm of 5 base 2 on Casio. Or let me use something that is very similar, something that is very simple. Logarithm of 8 base 2. I'm trying to explain this base now. Logarithm of 8 base 2. We know that Casio does not understand base 2 is automatically in base 10. So if you press log 8 in Casio, it's going to give you 0 point something, because he believed that you are talking about log base 10, but you are saying that you are talking about log 2. Then how can you convert it to what Casio understand? Is by converting that base 2 to base 10, so that it can give you the answer to be 3, because log 8 base 2 is what? 3. So how do we do that? All you need to write all you need to press is to press log 8 divided by log 2. It will give you 3 when you use Casio to solve that, because you are converting log 8 base 2 to base 10 now. That should be log 8 divided by log 2. So because it's automatically in base 10, so log 8 base 10 divided by log 2 base 10, that should give us a 3 now when you press that in calculator, because you have been able to convert from base 2 to base 10. Do we understand that? So now let's use all this law we have learned so far to solve some question in logarithm. Now look at this. You have to evaluate the following without using table or calculator as well. Look at the first question you're having here. You're having 2 log 6 base 3 minus uh, log 12 base 3 plus log 27 base 3. There's something I forget in this law. All these logarithm you're having here must be in the same base. So don't let me forget that they must be in the same base. We cannot apply this law when they are not in the same base. And that's why you know how to convert from one base to another. So let's go back to the question we are solving. So you are seeing that we are having this in base 3. All of them are in base 3. So now, look at this now. We are having 2 log 6 base 3. Why can't we apply the laws of definition of logarithm to this? Although this one means how many times can I raise 6? How many times can I raise 3 to get 6? Humanly, it is not possible for you to raise 3 to get 6. How many times can I raise 3 to get 12? Humanly, it is not possible for you to raise 3 to get 12. How many times can I raise 3 to get 27? That is possible. That should give us what? How many times? How many times can you raise 3 to get 27? That will be 3 times. So this answer for this one is 3. Log 27 base 3 is what? 3. So, but that's not possible for this, not possible for this. So that means you can apply the laws of logarithm. Since we have a minus and plus here, bringing them together. So you can apply the law of logarithm to solve that. So That means we are not going to use one law here. You can apply 2 or more logarithms to solve this question, depending on what is given to us. Look at this now. We are having 2 at the back here. So look at this law saying that when I'm having a number before the log, something should happen. That means this number should come to the power of this number here. So now we're having 2 at the back of this log here. What do you think it will be? So that means these 2 will go to the power of the number here. So you have a log 6 raised to power 2 base 3 minus log 12 base 3 plus log 27 base 3. Then what is 6 raised to power 2? That gives us 36. Then we can now rearrange it. I rearrange it based on believing that you are just learning this, but this can be solved without rearranging it, as we are going to see in the previous and so in the next examples. So I rearrange this. So I put 36 log 36 base 3, then followed by plus log 27 base 3 minus log 12 base 3. Then look at what you're having here. This one and this one, you're having plus there. That means you can apply the first law here, that whenever you're having log a plus log b, it can become log ab. So that means, let's go back. So you can pick log base 3. So then what do? This will be 36 times 27. Let's go back, please. So you pick one of the log, then you multiply these 2 numbers because you're having times here. So from there, that means you'll be having log base 3 into 36 times 27. Then minus, what does minus become? What does minus become? Minus becomes division. So that means minus log 12 base 3. That will be, you have this minus become division, then 12, close the bracket. So you can see that when you are combining this and this together, addition become times, division, subtraction become what? Division. And when you are applying it, you are having just single log, one log here into bracket, the simplification of the numbers. So it is when you are having addition and subtraction that you have different number having their log. But when it become multiplication and division, you have only single log, and the numbers are in the brackets here simplified. So from here, I can simplify this further. 36 times 27 divided by 12 give us 81. So the question is, how many times can you raise 3 to get 81 based on what you have done so far? So what this one means, that a log 81 base 3 means how often can you raise 3 to get 81? That's the answer is what? 4. So when you simplify this logarithm, you can see that the answer is what? 4. Do we understand that? Let's see another question. We are having log of sod 125 base 5 divided by log 25 base 5. If you are smart in thinking, you don't need to go through this. You don't need to go through this step before you can get the answer. How many times can I raise 5 to get sod 125? It is possible. How many times can I raise 5 to get 25? That should be 2 times. Is that not it? It is. So let's see this in action. So this can be written as a log of 125 raised to power half, because square root means raised to power half, over log of, you can change this one to index form as well. That will give us 5 raised to power 2. Then according to the law of logarithm, this power can go to the back of the log here or to the front of the log here. So that means you have a 1 over 2 log. Then you can now also change this 125 to an index form. So 125 can be written as 5 raised to power 3. 5 raised to power 3 give us 125. That will be 5 times 5 times 5 times 5 times 5 times 5. So 125 is same thing as 5 raised to power 3 over this power 2 also will go to the back here. So you have 2 log 5 base 5 as well. Then also this power, you can see that this number here is also having power of 3. So that means 3 also will go to the back as well. So you have 1 over 2 times 3 log 5 base 5 over 2 log 5 base 5. So what can we see? Everything here can cancel everything here. So log 5 base 5 can cancel log 5 base 5. Or what is log 5 base 5? That should give us 1. How many times can you raise 5 to get 5? That should give us 1. Also here, log 5 base 5 also give us 1. So from there you are left with 3 over 2 divided by 2, which you can change to times. That gives us 3 over 2 times 1 over 2. Then that should give us 3 over 4. So that means if you simplify this, you have 3 over 4. You are using the laws of logarithm to simplify logarithm as well. Let's evaluate a more technical question. We are having 1 over 2 log 25 over 4 base 10 minus 2 log minus 2 log minus 2 log 4 over 5 base 10 plus log 320 over 125 base 10. How can we simplify this also? How can we simplify this using the laws of logarithm? We can see that using the law of logarithm, this 1 over 2 will come to the power of this. Using the law of logarithm, these 2 also will come to the power of this. So we have a log 25 over 4 raised to power half minus log 4 over 5 raised to power 2 plus log 320 over 125. Then you understand what this one literally means. Raised to power half means square root. So you find the square root of 25, which is 5, square root of 4 is 2. Then this raised to power 2 means we have to find the square of 4 and 5. What is the square of 4? 16. What is the square of 5? 25. Plus log 320 over 125. Then from there, you can now apply that to solve further. You can now apply the law now to solve it further. You can now apply, since you can see that we have simplified it further, you can now apply the law to solve it further. What do? We can see that they are in the same base, fine. You're having minus here, so that should turn to division. You're having plus, that should turn to what? Times. So that means you have a log of base 10 into brackets 5 over 2 divided by 16 over 25. Then times, plus we change to times 320 over 125. Then we know that we can change this division to times. This will go up, this one come up, this one come down by inversing this fraction. 5 over 2 times 25 over 16 times 320 over 125. Then if you simplify this, if you cut, then you'll be having 10. 16 can go in 320, that give us 20. Then 2 can go in 20, that give us 10. Then 25 can go in 125, that should give us 5. 5 can cancel 5, so we have left with 10. Then log 10 base 10 will give us what? 1. How many times can you raise 10 to get 10? That should give us 1. Let's see another question using the laws of logarithm. You are having log of sod 15 base 10 times log of sod 6 base 10 minus log of sod 9 base 10. So they can see that they are all in the same base. So we can see apply the law of logarithm here. We are having, sorry, this is plus, not times. Change that. This is an error. This is plus, not times. So you have log sod 15 base 10 plus log sod 6 base 10 minus log sod 9 base 10. So change this one to plus, not times. So from there, since they have the same base, so you have log of, open the bracket, the addition will change to times, so you have log sod 15 times log sod 6, then minus change to division, divided by sod 9, then base 10. So if you understand the sod very well, sod 15 times sod 6 can be written as sod 16 times 6 over sod 9. Then sod 15 times 6 will give us a sod 90 over sod 9. And this can also be written as a sod 90 over 9, like this. So that this can be combined to a single sod, that's sod 90 over 9. 90 divided by 9 gives us a sod 10. And this sod 10 can be written as 10 raised to the power half, which is this. So, and we know that when you're having something like this, that a number is having power, the power will go to the back here, according to the law of logarithm. So you have log 10 base 10. and log 10 base 10 will give us 1. So half times 1 will give us half. So that means when you simplify this, the answer is half as well. So another example using the laws of logarithm is what you are seeing on the screen right now. We are having the log of 30 over 16. Sorry, log of 30 over 16 base 10 minus 2 log 5 over 9 base 10 plus log 400 over 243 base 10. This is also a question we can simplify using the laws of logarithm. What can be done? We can see that something can be done to this one. This 2 can go to the power of this. So we have 5 over 9 squared. Then we know that this 2 will affect 5, will affect 9. Since this is power, so we have 5 squared over 9 squared. That will give us 25 over 81. So now we can now apply the laws of logarithm to this since they have the same base. So what do? You pick the log base 10 into bracket 10 divided by 16. Minor will change to division, then 25 over 81, then plus will change to times 400 over 243. Then this division can be changed to multiplication. So what can be done? You have 81 over 25. When you inverse this one change to times. Then what can we do? From there, if you simplify this further, you discover that if you cut it and then simplify it further, you have it to be 10. If you simplify this, it's going to give us 10. It's going to give us 10. So then 10 raised to how many times can we raise 10 to get, and that give us 1. So if you simplify this, you just invert this, leave what I've done here, invert this 81 over 25, then start cutting, start reducing it, then you will get 10 raised to power 10 to give us so log 10 base 10 to give us 1 in this case. So now from there, let's go. Okay, let's look at, you have to solve this log 4 you have to solve for x in the log x minus log x minus 3 equals to log 7. Log x minus log x minus 3 equals to log 7. Then how do we solve this? If you look at what we have been solving so far, we have been solving logarithmic expression, not equation. So let's solve this equation now using the laws of logarithm. We're having log x minus 3 equals to log 7. So we know that we can apply the law of logarithm to this. This will be log into bracket s minus change to division x minus 3. So we have x divided by x minus 3 because everything here is a number. So equals to log 7. In this case, we are having single log here, so log can take care of log. So we have s over s minus 3 equals to 7. Then from there, we can cross multiply. So what do we have? We have 7 times s will give us 7x. 7 times minus 3 will give us minus 21 equals to x. We can collect like times here. So we have 7s minus x to give us 6s. This one comes here equals to 21. So divide both sides by 6s equals 21 over 6. And that should give us a 7 over 2. When 3 go here, it gives us 7 over 2. Also, and you can change this one to mixed number. That should give us 2 whole number, 1 over 2 for the value of x. Let's see another question that can challenge us. We have to solve for x in log x base a minus log 32 base a plus 2 log 8 base a equals to 0. So also, what do you do first? You consider that there's 2 here, you go to the power of 8. So that should give us 64. So yeah, then you can now apply the law of logarithm here now. Since you're having minus and plus, so you change to division, you change to multiplication. So you have a logarithm of base a into bracket x times 64 divided by 32 equals to 0. Are we there? Then from there, how many times can you raise a? is 0 to get x times 64 over 32. That's what this one literally means. Raise a raised to power 0 to give us s times 64 raised to power over 32. Although 32 can go in 64, that should give us 2. So 2 times s will give us 2x. So logarithm of a raised to power 0 to give us what? 2x, according to the definition of logarithm. So a raised to power 0 to give us what? 2x. So that should give us a raised to power 0 equals to 2x. A raised to power 0 is 1. So that gives us 1 equals to 2x. Divide both sides by x by 2 to get x. So x equals to 1 over 2 from there. So another way you can solve this as well is that in this case here now I can replace this one to be log of 1 base a, because we know that the log of 1 base a it gives us 0 according to the law that we have learned. Log of 1 base a will give us 0. So that means log of base a can cancel log of base a. So you have 2x equals to 1, which is what you're having here. Then s equals 1 over 2. That's another way of solving this question. Let's look at another question here. Find the value of x in the log s plus 1 base 10 minus log of s minus 1 base 10 equals to 1. So here also to the left hand side you can apply the law of logarithm, since you're having minus here. So you pick one of the log into bracket s plus 1, then minus become division, s minus 1 equals to 1. Then the definition of logarithm says that you can raise 10 raised to power 1 to get s plus 1 over s minus 1, which is what you're having here. So s plus 1 over s minus 1 will give us 10 raised to power 1. 10 raised to power 1 is the same as 10, so you can cross multiply here. So 10 will multiply s minus 1. You have 10 into s minus 1 equals to s plus 1. So if you open the bracket, you have 10x minus 10 equals to s plus 1. Collect like times from there. You have 10x minus x equals to 1 plus 10. So 10x minus x will give us 9x equals to 1 plus 10 is 11. Divide both sides by 9. That gives us s equals to 11 over 9. And that gives us one number 2 over 9 as the value of x for question number 8 here. Still on the using the laws of logarithm to solve logarithmic equation. Another question is what you are seeing on the screen right now. You have to find the value of x in log 3x minus 1 base 10 minus log 2 base 10 equals to 3. So from there, what do we do as well? You can apply the law of logarithm to the left hand side here. That should give us log 3 minus 1 divided by 2, y division because of this minus here, equals to 3. Then you can raise 10 3 times to get 3s minus 1 over 2. So according to the definition of logarithm, 10 raised to power 3 equals to 3s minus 3 over 2. 3s minus 1 over 2 rather. So 3s minus 1 over 2 equals to 10 raised to power 3. 10 raised to power 3 means 1000. So you can cross multiply from there. 2 multiply 1000, that should give us 2000 equals to 3s minus 1. Collect like terms from there. We have 3 equals to 2000 plus 1, which is going to give us 2001. Divide both sides by 3, s will equal to 2001 divided by 3, and that should give us 667 as the value of x. So we can also have a logarithmic equation that will result to simultaneous equation, or that you have to solve simultaneously. So that means you are given two equation on logarithm to solve simultaneously, like the one we are having on the screen right now. It is possible. Solve this simultaneous equation log x base 10 plus log y base 10 equals to 4, and log x base 10 plus log 2 log plus 2 log y base 10 equals to 3. So you're having two equations now to solve simultaneously. How do we approach this? So you can call this equation 1, you can call this equation 1, equation 2. What can we do? There's no cause for alarm indeed. This one is very simple. Why? If you look at this term and this term, they are the same thing. This one is one of these and this is two of these. One of everything here and this is two of these. You can say that this one and this one are the same thing, except from we're having two here. So one of these, then two of these. So what can we do? You can subtract equation 2, sorry, equation 1 from equation 2. we can remove equation 1 from equation 2, subtract equation 1 from equation 2, because if you do that, this one we cancel, it will be eliminated. So subtract equation 1 from equation 2, so that means you have log s base 10 minus log f base 10, that should give us 0. So you're having 2 log y base 10 minus log y base 10, that should give us 1 of that. That should give us log y base 10, because 2x minus x will give us x. I'm just using another term now. 2x, you see this one as 2x minus x, so that should give us x. So 2 log y base 10 minus log y base 10, that should give us log y base 10. Then 3 minus 4 give us minus 1. Do we understand this? Then based on our idea of a definition of logarithm, log y base 10 equals to minus 1 means how many times can we raise 10 with minus 1 to give us y? So we have y equals to 10 raised to the power minus 1. And 10 raised to the power minus 1 seems as 1 over 10. So the value of our y is 1 over 10. Since we know y, let's find x. So you can substitute for the y in equation 1. What's equation 1? Equation 1 says that log x base 10 plus log y base 10 equals to 4. So if you anywhere you see y, you put the value of y there. So that means you have a log x base 10 plus log our y here is 10 raised to the power minus 1. So 10 raised to the power minus 1 base 10 equals to 4. So you should be able to tell me the value of this answer here. That should give us minus 1. Because if your minus 1 come to the back here according to the law of indices, because this one is having power indices here, so you're having minus 1 here. So minus 1 times minus times plus will give us minus. So then log 10 base 10 will give us 1. So you're having minus 1 times 1 they give us minus 1. If you don't understand that this minus 1 comes here, you become this, then you have log 10 base 10. I hope you understand this now. So this one will give us 1. 1 times minus 1 will give us a minus 1 here. So you're having the log s base 10 minus 1 equals to 4. You can collect like times. So 1 will come here. So minus 1 will come here, become plus 1. So you have log s base 10 equals to 4 plus 1. 4 plus 1 will give us a 5. So we can raise 10 5 times to get x according to the definition of logarithm. 10 raised to the power 5 could give us what? X. So s to be equal to 10 raised to the power 5. So s will be equal to 100,000 as the value of x. So x is 100,000, y is 1 over 10 for this simultaneous equation on logarithm. So if you understand what you have been doing so far on the using of laws of logarithm to solve logarithm questions, then you can try this 6 question out also as a self-evaluation questions, so as to help you understand logarithm very well, or laws of logarithm very well. So lay your hand on those questions. They are past examination questions. Although you have been solving all the questions you have been solving so far, they are past examination questions as well. But I want to give you this one so that you can lay your hands upon them, so that you will see, you understand better what we have done. If you look at the last question, it's on simultaneous equation as well. But in this case, you can see that this and this are equal, but this and this is twice of this one. So you can just add instead of subtracting. Now if you add this one and this one will leave, y will leave, log y will leave, then you can now deal with log s. When you now deal with that, you can now find your log y back. So try this question yourself, so that and leave the answer in the comment section of this video, so that I will respond to them. Now before we stop this video, there are other parts of logarithm that are related to laws of logarithm, and that is the logarithm we are seeing on the screen right now. When I'm giving some predefined values of logarithm to now use them to solve other logarithm, I'm giving some predefined values of logarithm to use them to solve other questions without using tables or calculation or calculator. For an example, you are given the value of log 2 to be 0.3010. You are given the value of log 3 to be 0.4471. Value of log 7 to be 0.8451. You have to evaluate log 108, log 35, log 1 over 3, log 0.49, log 13.5 using these predefined values of logarithm given to us. It is also possible in logarithm, and we're going to discuss it extensively in the now. But before you attempt this kind of question, given the predefined values of logarithm to solve other logarithm, there are some things there are things you must know. There are other values of logarithm that they expect you to know offhand. There are other values of logarithm they expect you to know offhand before you can do something like this. What are the logarithm? They expect you to know the value of log base 10 of 10. You should know the logarithm of 10 base 10 rather, which is what? 1. Logarithm of 100 base 10, 2. Logarithm of 1000 base 10, 3. They expect you to be able to know this one offhand because sometimes you will need them in simplifying something like this. I hope you understand what I'm trying to say. So if you understand that, let's try to solve this question one after the other. Let's start with log 108. All you need to do is to simplify or look for number you can multiply together to give us 108. Look for number you can multiply together to give us 108. And those number can be derived, that can be simplified further to see all these numbers from it, either these 2 or 3 or 7 or 10. So if you simplify log 108, I can get 108 by using 27 times 4. 27 times 4 will give us 108. But we are not giving 27, we are not giving 4. But I can still simplify 27 and 4 further to showcase 3 and 2. How? Okay, before we do that, using the laws of logarithm, when I have log 27 times 4, this is multiplication. This can be broken down to what? Log 27 plus log what? 4. You see, remember the laws of logarithm? Fine. Then I can break 27, I can find the index of 27, that should give us 3 raised to power 3. I can find the index of 4, that gives us 2 raised to power 2. Do you understand this now? Then you can see that we are now having 3, we are now having 2 here. And this power, according to the law of logarithm, should go to the back to go to this point. So you have 3 log 3 base 10, and this 2 also should, this power of 2 here should go here as well. You have 2 log 2 base 10 as well. So you can see now that we are now left with 3 times log 3 because we know the value of log 3. And we are left with 2 log 2 here, and we know the value of log 2. So substitute the value of log 2 here, substitute the value of log 3 here. So you have 3 into 0.4771 plus 2 into 0.301. If you multiply this by calculator, you have 0.602. Multiply 2 by this, 1.4313. And if you add this together, that should give us 2.033. So you can see how we have been able to find the logarithm of 108 using the value given to us. Let's find the value of log 35. Log 35 can be done as you can represent log 35 as a log 7 times 5. 7 times 5 give us a 35. And I can also use 35 to be log 70 divided by 2. 70 divided by 2. Instead of using 7 times 5, I can use 70 divided by 2. Then from 70, since I don't have the log 70, I can use 7 times 10 to give us 70 over 2. So since I know the logarithm of 10, and I know the logarithm of 7, and I know the logarithm of 2, I can use that. Or I can use this as well. 35 log 35 is the same thing as 7 times 5. Are we there? Which can be broken down to addition because this is multiplication. We have log 7, then plus log 5. We have value of log 7, but we don't have the log of 5. Do we? We are not giving the log of 5, so we are giving log of 7. So this one is settled, but we have to simplify the log 5 further. How? You agree with me that the log 5 can be written as log 5 can be written as a 10 over 2. 10 over 2 will give us 5. Is that correct? Good. Then this also now can be broken down to log 10 over 2 can be broken down to log 10 base 10 minus log 2 base 10 because this division can change to what? Minus. So we have log 10 minus log 2. Do we understand that? Good. If you do that, then we know the value of log 7, which is this 0.8451 plus log 10 base 10 is what? 1. Although we are not giving, but you are supposed to know this one offhand. then minus log 2 is given 0.3010. And if you simplify this, you have a 1.441 as the value of log 35 base 10. Do we understand this? Good. If you let's simplify the next one, log 1 number 1 over 3. You have log 1 number 1 over 3 base 10. This you can first of all change to an improper fraction. 3 times 1 will give us 3 plus 1 will give us 4 over 3. And this now we are having log 4 over 3 base 10, which can be changed to, this division can change to minus. So we have log 4 minus log what 3. We are given the value of log 3, but we are not given the value of log 4. Then we can see simplify log 4, this 4 bit further to derive 2 from it by changing it to index form 2 raised to power 2. Then this power of 2 will go to the back here according to the law of logarithm. Then we have 2 log 2 minus log 3. We know we are given the value of log 2, which is 0.301. We are given the value of log 3, which is 0.4771. If you simplify this, you have 0.1249 with your calculator. So now for question number D, you're having log 0.49 base 10. Log 0.49 base 10, we can change this one to a fraction. So this can be written as 49 over 100, which I believe you know how we got this. 1, 2, you have 49 over the 100. Then, excuse me, this can now be breaking down using the laws of logarithm to be log of 49 minus log of what? 100. Do we understand this? Then this 49 now, we are not giving log of 49, but we can get log of 7 from 49 by changing 49 to an index form. That should give us 7 raised to power 2. Then we know the value of log of 100 base 10. What is log of 100 base 10? That should give us 2, because we can raise 10 100. You can raise 10 2 times to get what? 100. So from here now, 2 can go to the back of the to the front here according to the law of logarithm. So you have 2 log 7 base 10 minus log 100 base 10. So we are given the log value of log 7, which is 0.8451. Then multiply by 2 minus 2. So if you multiply this by this, that gives us 1.6902 minus 2, and that should give us minus 0.3098. So the log of this value is minus 0.3098. The last one is a log of 13.5 base 10. But to simplify this as well is very simple. All you need to do is to change this one to a fraction, because it's a decimal number. We have 135 divided by 10. So which can be broken down because of this division to minus log 135 minus log 10 base 10. We know the value of this, but we need to simplify the log of 135 further. And if you multiply this by this, sorry, if you simplify this, you can give us you can get 135 by multiplying 5 times 27. Are we there? Although we are not, you don't have the value of log, we don't know the value of log 5, we don't know the value of 27, so you can still simplify them further. So this can be broken down to, because of times, to log 5 plus log 27, then plus log of 10 base 10. Then log of 5 can be broken down to log of 10 over 2. 10 over 2 will give us 5. Then log of 27 can, 27 can be written as 3 raised to power 3. Then that power will come to the front here. That should give us 3 log 3. Then minus log 10 base 10. Then this also can be broken down to log of 10 minus, because of this division, to log of 2. Log of 10 minus log of 2 plus 3 log 3 minus 10 base minus log 10. So now log of 10 base 10 is 1, minus we are given the log of 2 to be 0.301, plus 3 multiplied by the log of 3 is giving 0.4771, minus log of 10 base 10 is 1 as well. So if you simplify this as well, you have a 1.1303 as the log of 13.5. So we have seen how we can use some predefined values of logarithm to solve other logarithm given to us as well. So if you understand what you have done, you can try this one question on your own, given the value of log 2, log 3, and log 5. You have to evaluate without using table or calculator. Log of 4.5 base 10, log of 0.72 base 10, log of so 30 base 10 as well. So that is all we have for you for this video on logarithm, and I want to believe you have been able to learn one or two things on logarithm, whether by using the definition of logarithm or using the laws of logarithm to solve logarithmic expression or equation. In the next video, we are going to show you how you can use the four-figure table to solve logarithmic question as well. Thank you for watching this video. If you are yet to subscribe to this channel, please click on this subscribe button right now on the channel. You see a subscribe icon. Click on it, and you can also click on the bells for notification whenever we post video on this platform. Please do share the video with the student out there who need this resource material. It is useful for both general mathematics and further mathematics students. And I will see you in the next video. Bye, and God bless you.